Look at naming ionic compounds. So the fancy word for naming compounds is nomenclature. So we're going to be learning about ionic nomenclature today, where we're just um, naming compounds that have a metal and a non-metal, or a metal and a polyatomic, okay? All right, so we already created these Lewis dot diagrams when we were making the Bohr-Rutherford diagrams, and then we went and drew the Lewis dot diagrams because these dots here represent the electrons that are on the very outside electron shell. So basically, that there was a pattern with the number of electrons in the valence shells as we went across the table here. So in the first column here, the first group here, they all had one, then two, and then we skip. So if we were comparing it to the periodic table here, we skip this whole section here, and then we go to these ones here. So it's 3, 4, 5, 6, 7, 8. Okay, except helium only has the 2 to make it full. All right, so the number of valence electrons that it has affects its physical and chemical properties. And so if we're looking at it from a stability standpoint, we're seeing here that there's one valence electron, two valence electrons here. So they're not very stable. So they would rather get rid of these electrons, and then when they do that, they go into their inner ring of a stable 8 electrons and so forth. So what's going to happen here is if you give away your electron, you're less negative, so you end up becoming positive. So these end up taking on a positive 1 charge for this column, this group, and these ones are a positive 2, this group here, because they're going to get rid of 2. All right, so you got rid of your electrons, you're less negative, so now you're more positive. All right, and then if we look on the other end here, so here we'll get rid of 3, okay, and then with these ones here, we'll call it 4. So basically, I know that with 4 electrons is a tie, in the sense that, well, if a full shell is 8, so if we're at the halfway point 4, which way does it go? Does it lose these electrons or does it gain 4? So in this case, we generally see more that these guys will lose the 4 electrons, okay, to become stable. So generally has a plus 4 charge, but again, depending on the scenario, it may vary. But for now, just in general, plus 4. All right, so these other ones where there's 5 electrons, 6 electrons, 7 electrons in the valence shell, it's easier for them to pick up some electrons. So for, like, if we look at this column here, they have 7 valence electrons. So all they need to do is pick up 1 electron, and then they'll be stable. So in this case here, you have a -1 charge because they have that extra electron. Okay, these ones will pick up 2, and these will pick up 3. So they end up with those charges. Okay, and then the noble gases, the very last column here, they're already happy. They have a stable octet, or helium has the full shell here, so they won't have a charge. What I want you to do here with the table values, so this is a small version of your table values, or periodic table. What I want you to do here is I want you to just jot down the charges at the top, okay? So over here, these are always +1, okay? These are always 2 plus, okay? I always write the charge after, okay? Then we skip, then we have 3, 4, right? Oops, positive, and then from here, we end up grabbing electrons, right? These guys, all the positive ones will lose electrons. These ones will grab them. All right, so just kind of have those there so that when you are today creating compounds, you'll know what charge they have, and then that'll help with naming and so forth. The reason why we skip the ones through the middle here, is because with these transition metals, they can take on several different charges. And so we need some other clues. So we can't assume it's going to be 5 or 3 or 2. We need some clues here. So what you're going to find is that there's going to be a Roman numeral clue. And so then from there, you'll know what charge it has. Okay, so just here's a little key, I guess, so that if you can't remember your Roman numerals, you can kind of look here. All right, other things that you're going to see today are some polyatomic ions, so I'll refer to this. So the main thing here is make sure you have your periodic table handy while we're going through this lesson. And then on the back of it, it has the table of polyatomic ions. So if I show you here, this is what's on the back of your periodic table. So here is a big table here of polyatomic ions. So that's what we're going to be analyzing today. So just be flipping, your periodic table back and forth with this side, and yeah, so that way it'll help with naming today. I'm going to start with the binary ionic compounds. So basically, these are the simplest ionic compounds that we'll start with, and then we'll kind of ramp up as we go into the more complex ionic compounds, okay? All right, so what you're going to see here, we'll start with, okay, if I give you a chemical name, can you come up with the chemical formula? We'll start with that first. So I'm going to I have a little, I guess, step-by-step instruction part here. I have a visual diagram, and then I'm also just going to go through and show you an example. So just kind of use what you need here in order to figure out what to do here. Okay, so what I usually do is I look at the formula or the chemical name, and then I will write the element symbols underneath. So looking at your periodic table, magnesium. Okay, so again, have that periodic table close by, so you're always staring at it so you can find things really quickly. So magnesium is Mg, oxygen is O, okay? So that step is done. So the next step here is we're going to write the charges. Write the charge on each element at the top right. So we're going to put it in this area here. So if we look back at our charges here, magnesium is right here. So if magnesium is right here, that's a 2+ charge, and oxygen always has a -2 charge. So let's put those on and put them in the top right like that. Oops. So I always write 2+ and then 2-. Okay, so from there, so we have that step done. There's a couple of different methods you can use. There's the crisscross method, which a lot of people like, but there's also the balancing of charges method that you can use. So I'll show you both. So I'll start with the crisscross first. So what a lot of people do is they write the ions here, the elements with the charges, and then they crisscross. So they send that 2 down over here. So maybe I'll do that a little better. So they'll send it there, and then they'll send this 2 here. Okay, the charge on the O goes there. All right, we're going to leave the charges behind. We're just going to write the numbers that came down. Okay, so we get Mg2 and O2. Okay, so this 2 came here, that 2 went there. All right, so and then from there, we're almost there. I want you to reduce the subscripts if you need. So in this case here, we have Mg. Sorry, both of these can divide by 2, so you can reduce it. Okay, and then whenever we have a subscript of 1, we don't write it. So we just write MgO like that. Okay, all right, so there's magnesium oxide as a chemical formula. All right, so if we want to look at a visual diagram, here's sodium chloride. So again, here's the cation, that's the metal. Okay, the anion here, it's negative. That's positive. So we have sodium, we write the charge on, because if you look, sodium, which is here, is +1, chlorine is -1. Okay, so then what we do from there is we crisscross, or we can do the balance method, and then we end up with sodium, end up being sodium and chlorine like that, but then we reduce it to sodium chloride like that, NaCl. Okay, so actually before we do the next example, I promised that I'd show you the balance method, okay, the balance charge method. So back here, if we are back at the step here where we wrote the element and the charges, we want to look here and go, okay, we want to make sure that the charges balance out. So basically we have a +2 here and we have a 2- here. So see how they are the opposites here? So, if you think of it as math integers, if you were to add them up, you would end up with 0. So you want to have a balance of 0. So since you have that, that means, well, you need 1 magnesium to 1 oxygen to balance the charges out. So you would just say, oh, MgO. Okay, so this is the, the balance charge method. Okay, and the first one I did here was I don't know, people call it the crisscross method because you crisscross the charges. Okay, so it just depends on if you're just more of a visual person, you need to see those numbers move, or if you're more mathematical and you want to just balance out the charges, you can do it that way. Okay, all right, so we'll keep using both methods as we go through. So let's try the next one here. We have barium sulfide. So if you want to stop the video and try it on your own and then start it and double check. All right, so barium, I'm looking at the periodic table. So again, you want to get good at finding these, and if you're ever stuck during an assessment and you can't find something, just ask me for help. So that's beryllium, barium's right here, okay? And then the other one was sulfide, sulfur, and that one's there, okay? So barium has a 2+, sulfur has a 2-. Okay, so if we use the crisscross method again, we're going to have the 2's come down, and then you can reduce it, and then you get 2 barium BAS, okay? All right, otherwise, if you wanted to use the balance charge method, okay, you can see again, they're already balanced, so you just need 1 barium to 1 sulfur, and then you're done. All right, so hopefully that was enough examples there. I guess we saw a couple there where they actually they balanced out. So I don't know if you wanted to do another one here. I don't know, just so maybe magnesium chloride. Okay, so here this would be magnesium 2+ and chlorine -1, like that, and so I just write negative like that. All right, so if we crisscross those, we end up with magnesium with the 1 and the chlorine with the 2, like that when we crisscross. And then we just, we can't reduce those, but I'm not going to write the subscript 1. So there's magnesium chloride. Okay, and if we use the balancing of the charges method, okay, so we can see here with the magnesium, there's 2+ charge here and a -1 here. So we don't have enough chlorines, right? We don't have enough negatives here. So what I would do is I would add another chlorine in like that. So see how I have a -2 charge now and a +2 charge. So it's all balanced. So what did I need? I needed a ratio of 1 magnesium and 2 chlorines. Okay, and it gets to the same formula. All right, let's move on to going the other way. So what if I give you the chemical formula? Can you go back to the chemical name? Okay. So here are the instructions. You're going to write the name of the elements out correctly underneath, and then just make sure the cation is first, the metal, then write the anion, okay? And then for the second element, the anion, you're going to change the ending to an IDE ending for these basic ionic compounds, okay? All right, so here's a visual here. We have aluminum, so we have AlF3, okay? So what we're going to do is, okay, that first one's the metal, that's aluminum, okay? The second one is fluorine, so I'm writing fluorine out, fluorine, okay? And then, so when I go to combine them, I just have to change the ending of the second one. So it's ene right now, so we're going to change it to ide, it's fluoride, okay? And then write the final name here. All right, so we'll do the same thing here, these examples. So I have calcium, and I have bromine, whoops. Like that. Okay, but then what I'm going to do is I'm going to change the ending here, and then I'm going to write calcium bromide. Okay, and if you're wondering, could I have just skipped right to this step? Yes, you can. Okay. All right, so here's the next one, BeF2. So again, this is beryllium. So since you have a periodic table that you can copy off of, I want you to spell things correctly. So just make sure that you're actually copying that off correctly off the periodic table. Okay, this one's misspelled a lot. So same with the next one, fluorine. Okay, so it's fluorine like that. Okay, but then we're going to change the ending here to beryllium fluoride. Fluoride, like that. Okay, in beryllium, like sometimes the L's go missing, the Y goes missing, so just that's why just be careful. Okay, all right. So yeah, there's the chemical names. Okay, so we went from the name to the formula, and from the formula to the name. So hopefully it's a little easier going this way. Okay, so that's when it's just some basic ionic compounds where it's the metal and the non-metal. The metal only has one type of charge, the anion, the non-metal only has one type of charge, so it's nice and easy, okay? All right, so the next kind, so actually before we go to the next kind, I want you to practice these. So just stop the video and go and practice a bunch of these with the worksheets that are posted. When you're good, I want you to start the video again and move on to the next ones here. Okay, so these are the multivalent compounds. So what's different about these ones compared to the other ones is that the metals that we're going to grab now are coming out of this region here. So this middle part here, okay? So here, these ones always have the same charges. Sometimes the +3 and +4 can vary, but generally, you know, the first one's 1 + 1 + 2, and then -2, -1, okay? So, so what's happening now is we're going to be grabbing stuff out of here where the charges on the metal can vary, and we'll place it with the non-metals that, you know, have these general charges of -2, -1. Okay, so what we're going to see here, we're going to start seeing those Roman numerals, so just kind of keep referencing back to here. All right, so here are the instructions. So basically, we're going to start with the name, and we're going to get it back to the formula. You're going to write the symbols underneath, okay, the chemical symbols underneath, and then we're going to write the charges on, and then kind of use the same methods here. So what's different is that the copper is from that middle section of the periodic table, so we don't know what the charge is. So what you're going to see in the name is that you'll see the Roman numerals with copper. So any kind of multivalent metal, well, if it has more than one charge, it'll have the Roman numerals. If it doesn't, like zinc, if you look up here, like zinc is kind of in this section here. Zinc is always a 2+ charge, okay? So you'll see it kind of in this corner here where the charge is. For these other ones here, you'll see that there's more than one charge listed. So yeah, so then that's when you need to see that Roman numeral. Otherwise, they're like cadmium, silver, they're all like, they all have a specific charge. They don't have more than one charge. Okay, so if it doesn't have the Roman numeral, just treat it like any of the metals up here. If it does, you're going to use it as a guide to help you identify the charge. So I'm going to write copper is Cu and a 2+ because it has the Roman numeral 2 here, okay? All right, and that Roman numeral belongs to the metal, not to the anion here, okay? So this is fluorine. Fluorine is, again, part of this group here where it's always -1. Okay, but I'm just going to write negative like that. All right, so again, if you want to use the crisscross method, you can flip the signs, the numbers down, leave the charges behind. All right, and then we don't write the 1, so we write Cu and then F2 like that, okay? And if we're using the balance method, the charge balance method, okay, so it's more mathematical. You have a +2 charge here, you have a -1. You don't have enough negatives, so you're just going to add another fluorine like that to make it a -2 charge and have +2 charge. All right, it's all balanced. So that means I need a ratio of 1 copper to 2 fluorines. Okay, and so hopefully that was okay. So let's try another one here. So if you want to stop the video, you can try it on your own and then start it again. All right, cobalt. So same thing. Just get comfortable with looking at the periodic table enough that you'll find cobalt. So again, I'll help you find it here. So copper was here. Cobalt is right there. It's kind of a few over from copper. All right, so cobalt again is a multivalent metal, so we need more specifics on what charge it will have. So it'll tell us with the Roman numerals here. So 1, 2, 3 lines like that is 3. And sulfide always has a -2 charge, okay? All right, so if we crisscross these, okay, the 2 comes out down to cobalt here, sulfur gets the 3. We always make a little check here to see if I can reduce them, but nope. So then you have a formula, Okay. All right. If you're using the charge balance method, okay, you're looking at, oh, okay, this is a little trickier. We have a +3 charge and we have a -2. We need to get it to be the same. So what you can do here is, again, you can kind of keep drawing. So you can kind of draw it with this and go, okay, if I add another sulfur, I end up with a -4. Okay, so then now there's too much negative. So then you'll add a cobalt and go, okay, so then I have an extra cobalt. Now it's a +3 charge. Now I have too much positive charge. So then you go back to sulfur and add another one. And now you're like, oh, that's -6. This is +6. All right, we're finally balanced. So what was the ratio that we needed here? We needed 2 cobalts and 3 sulfur to balance out all the charges. Okay, and then it ends up being the same as the crisscross method. So again, use whatever method that works. I think some people like the balance method because it kind of makes sense that you're trying to balance out the charges and figure out how many of each that you need. The crisscross is nice, but you just got to remember to reduce if you're going to use that method, okay? All right, so hopefully that's enough examples for chemical name to formula. So now we're going to go the opposite direction. All right, so what if we have the chemical formula? Can we get back to the name? All right, so here are the instructions here. You need to, it's like reverse crisscross, okay? Or reverse the charge balance method, okay? So I'll show you how to do those there. And then you're gonna look to see if, so for example, you know what the charge of chlorine should be. It should be -1. So you're gonna do a check to make sure that it makes sense. Is the charge correct? If not, you're gonna have to correct it. And then from there, you can write the name after that. So right now we're just trying to figure out the charges and then we'll write the name after, okay? And because we are dealing with a multivalent metal here, you will need to write the charge in Roman numerals, okay? All right, and yeah, and then eventually the second one has an IDE ending. All right, so let's just we'll use the crisscross method here. So what I'm gonna do is reverse crisscross. So we know that this one has a 1 and that one has a 2, so we're going to reverse them. So this 2, think of it this way, goes over there, and this 1 goes over here, okay? So if we do that, that means tin, this is tin, ends up with a +2 charge, and chlorine ends up with a -1 charge. Okay, so does that make sense? Right, the 2, so if we were to, crisscross it again, we'd end up back to this formula. So we're just doing an inspection here. Does this make sense? The one that we know for sure is chlorine. We know the charge of chlorine. So what is it normally? It is right here, okay, and it has a -1 charge. So that makes sense. It's good, okay? So the charge is correct. So therefore, this is the correct charge on the tin. All right, so we know the tin has to have a +2 charge. So now we can start writing out the name. So we're going to write tin, okay? But because it's multivalent, we are going to specify that it's tin 2, like that. All right, and then we're going to write chlorine here, but instead of chlorine, we're going to change the ending to chloride. So we have a tin 2 chloride compound here. Okay, all right, and again, if you want to stop the video and try this one now on your own, you can do that. All right, so PB, you're like, what is that? So you're looking here, or actually we can look at it in a sec, but PB right now, let's just do the reverse crisscross here. Okay, so we'll chuck the 2 up to the lead, okay, and the sulfur, we'll chuck this -1 up here, okay, so I'm just going to write the -1 in. All right, so the one we know for sure is sulfur, so if we take a look, okay, so right now sulfur is right here. Okay, it's in the -2 column. So right now the charge on sulfur is incorrect. So we have to correct it. Okay, so what we're going to do here to correct it is we're going to multiply this by 2, right? And then therefore multiply the other ion by 2. So we're correcting the charges here. Okay, because it's kind of like you reduced it, so you're going backwards now. All right, so now the lead here gets a +4, the PB gets a +4 charge, and sulfur gets a -2 charge, which is correct. Okay, so this is us correcting to make sure the charge makes sense. So now that we did that, we can go through and name it. Okay, so this is lead. okay, and 4 is IV, like that, sulfide. Okay, and also you can, I'm okay if you write the pH version, because again, you'll see that actually in books and online and stuff like that. So they used to write sulfur with the pH, now they write with the F, so both ways are acceptable, okay? So now I didn't show you the balance or the charge balance method, so I'm going to do that now. So here's the charge balance method. So again, we're starting off with SnCl2, okay? So if we were to look at these separately, so we have one Sn, so I'm going to pretend we don't know what that is, and we have two chlorines, so I'm writing two of them like that, Cl, Cl. So we know the charge of chlorine is -1 and -1, right? So since we have a -2 charge here, what does Sn have to have in order to be balanced with the two negative chlorines here? Well, we need a +2 charge on it, okay? So that's how you can use the balance method, the charge balance method, in order to find quickly the charge on the metal, okay? All right, so then from there, if you're trying to find Sn, you go up to the periodic table, okay? And Sn is right there, okay? It's tin. Okay, and so I would write tin, and because it's multivalent, 2 chloride. Okay, just like we did on the other side. Okay, all right, and let's do this one, PbS2. Okay, so same thing, we'll write out all of the elements that make up this compound. So we need a couple S's and one Pb, okay? So what charge does S have? Well, sulfur. They both have a -2 charge. So what's happening here is that there's a -4 charge. So to balance this out, lead has to be +4. Okay, so again, it's a different way of doing these. You just pick the method that you like and just roll with it. All right, so Pb, where is Pb on the periodic table? Okay, Pb is right there. Okay, it's right under tin. All right, so that's lead. So you're going to write lead, and because it's multivalent, you have to specify that it's lead 4 sulfide, like that, okay, with an IDE ending. All right, so you just finished your multivalent compounds. Okay, so again, it's just like your binary compound or your simple compounds here. You just have to specify what charge you have with the multivalent metals here. Okay, all right, so again, stop the video and practice the multivalent compound questions, okay, until you're really good. All right, and then when you're good, come back and we will do the polyatomic ions. Okay, so the last ionic compounds that we'll look at today are the polyatomic ions, okay, the ones with polyatomic ions. So way that these are different is that you're going to be dealing with, so like if you look here, you're going to have more, if it was a formula, more than 2 elements. You're going to have 3 elements or 4 elements or more, okay? So when you have that case, you likely have a polyatomic ion. So, if you have something that doesn't end with an IDE ending, again, it's likely a polyatomic ion. There are some polyatomics, though, if you take a look here, that do have an IDE ending, like hydroxide. So again, if you don't see a hydrox element on the periodic table, like we have hydrogen, right? But we don't have a hydrox type element. So then if you see something a little odd, then come and look at the this table here, the polyatomic table, and it's probably here. Okay, so most of these end with ate or ite, or like it just has different endings here, but we do have a few ides, like peroxide. Same thing, peroxide's not one of the elements. Let's see here. Yeah, I think those are the only two that have ides ending, or cyanide here, cyanide as well. So again, so just kind of look here if it's different. Otherwise, if it doesn't have an IDE ending, it's a good, just come and look here right away. So um, yeah, so that's what we're doing today. So if it has lots of elements or it has a different ending, I want you to look at this table right away and figure out what it is that we're dealing with, okay? So you're gonna find that we're combining all of the rules from above, where if you have a multivalent, you use those rules as well. And if it's just a simple metal, then you know what charge it should have and so forth. Okay, so now hopefully you're looking at copper 2 nitrate, and you're looking at the 8 ending and going, oh, polyatomic. You're looking at your chart here and you're looking for nitrate. So NO, where is it? Right there, nitrate, NO3, okay? All right, so what you're gonna do here is you're gonna write the element and the charge. So you have copper, it's a Roman numeral with it, it's multivalent, it's telling you the charge. Nitrate we found on our polyatomic table is that. And then from here, it's kind of the same idea. We're gonna do charge balance, or we're gonna do crisscross, and we'll get to our final formula. Okay, so we'll use the crisscross method first. So this 2 will sit here. Remember, this is like a 1, it'll go over here. So we'll write this again. So we have to go copper, copper. Okay, that 1 comes down, and then NO3, and then this 2 came down. All right, so what's going to happen here is that 2 just came down, right? So when we do that, if we don't have a bracket here, it looks like we have 32 oxygens, and we actually don't have 32 oxygens. So what you want to do here is you want to take the step of putting this bracket in like that, okay? So whenever a number is coming down to the polyatomic, put a bracket in, okay? And then put the number outside the bracket. All right, so we have copper 2 nitrate, okay? So if we write the final answer here, so we don't write the 1, we're going to write it with a bracket though, to show that there's 2 of these nitrates and 1 copper. All right, so that's the crisscross method. So if we want to use the charge balance method, okay, so again, there's a +2 charge, and we have a -1 charge overall on this clump of elements here. Okay, so it's a polyatomic. Poly means many atoms, right? Many atoms. That's why it's polyatomic. Anyway, so we have an overall -1 charge. It's not just on the oxygen, it's on the whole thing. All right, so right now it's not balanced, so I need another nitrate to balance out the charges. Like that, okay? So since we needed another nitrate, in the end, we need a 1:2 ratio of these. So in order to show that, you need to write the nitrates in a bracket to show this whole clump here. Well, we need 2 of those, and we need 1 copper. Okay? All right, so again, pick your method. If you like using them both, go ahead. That's good too. All right, so the next one here, it's a little tricky, but just kind of figure out, what do we have here? Ammonium. We've never had that element. Okay, if you kind of scan through the periodic table, you won't find that. So in this case here, the first one here is a polyatomic. Okay, so go and see if you can find it on the polyatomic table. Okay, so if you're looking at the polyatomic table here, we have ammonium right there, ammonium. Okay, so that is an NH4 ion. So NH4 with a +1 charge. All right, if we look for phosphate. Okay, phosphate, nope, right there. Okay, PO43. Okay, so there they are. All right, so we have a couple polyatomics here creating a compound ammonium phosphate. Okay, so if you want to use the crisscross method, you can do that. So again, remember when a number comes down to polyatomic, put brackets around it. Okay, so we're going to put brackets around this ammonium, NH4. Okay, so that 3 will come here, and then we could put brackets around the phosphate. Okay, and then that 1 will come down here like that. Okay, so, and then from there, this 3 is still here, so we need to keep those brackets on the ammonium. All right, and then here it's just a 1, all right? So because we can drop the 1, we don't need to write brackets on the phosphate. So ammonium phosphate, this is what the formula will look like. You have brackets on the first one, but not on the second one, okay? So whenever one comes down, you don't need that bracket on it. Okay, and charge balance method. Oops. Just make sure you write the ions out correctly. All right, so from here, so again, it's not that it's on the oxygen, it's the whole thing is -3. This whole thing is a +1 charge. So right now we're seeing that it's not balanced, so we need more ammonium ions to balance out the charge. Okay, so that it's up to +2, we need another one. Okay, now it's at +3, -3. All right, the charges are balanced, so I need 3 ammoniums, okay, to 1 phosphate. Okay, and I don't write the charges, right? I just write them together, showing the ratio of the ions together. Okay, so hopefully that was enough practice. You can go from name to formula. Okay, last examples here. Can you go to from the formula to the name? All right, so again, right away, you should be able to identify what kind of problem you have here. So again, right away, you're looking and seeing that there's a clump of elements or atoms together. So right away, alarm bell should go off, polyatomic, right? So same with this one, PO4, polyatomic, and so forth. So what you're going to do from there is identify what type of polyatomic you have, because right away you can see that Ca is calcium. Okay, so let's go and look for CO3 on the polyatomic table here. And CO3, there it is, carbonate. So calcium carbonate. So again, I just wrote them right out because I know that calcium is just a regular metal. It just has a 2+ charge on it. And, and then that way I didn't have to really worry about the charge on carbonate or anything like that. So I don't need any Roman numerals. Just write the formula straight out. All right, here's the next one. Or we can even look at the picture example here, magnesium hydroxide. So I know that it's so I'd write out the element. Okay, and then hydroxide. Okay, so it's on the polyatomic table as well, hydroxide right there. Okay, and then there's no issues with the metal being multivalent, so we just combine them together by crisscrossing or balancing. Oh, sorry, I guess I'm doing what I did above. Okay, so this should be up there, I guess. All right, so with this one here, so we'll go in here, potassium and phosphate. Okay, so sorry, let's look that up first. PO4. And where did that one go? Right here, okay? PO43. Again, this isn't multivalent or anything, so I know I could just write phosphate. Okay, all right, so hopefully that was enough examples. Please practice more these ones as well now. Do it till you're really good at them, okay? Because I want you to think of this lesson with learning how to name things as becoming literate in chemistry. If you can't read the formulas, you can't write the formulas and the names and so forth, it's like being illiterate in chemistry, and you're going to struggle with what the lessons that are to come. So just please practice these. Do lots until you're really confident and you're not thinking about what rule it should be and so forth, okay?